All right, so we're coming back to the law of cosines today. Now, I'm just going to give it to you right now, and then we'll talk, and we'll give it to you and use it today, and then we'll kind of see where it comes from tomorrow. All right, so here it is. So you want to copy down this box right here. This is the law of cosines. I will make it more than a tiny bit bigger. How's that? Okay, now, here's the thing. I also, underneath this, I want to do this. I kind of want to talk about this also because I don't think this was as clear as I wanted it to be. Law of sines, you're going to use angle, angle, side, and angle, side, angle. And then we have the ambiguous side, side, angle. So that's the law of sines, okay? Laws of cosines. Law of cosines, it's going to be for SAS and SSS. Okay? So that's when you're going to, because you have to know when to use the law of sines and when to use the law of cosines. Law of sines is going to be angle, angle, side, angle, and sometimes SSA. And then law of cosines is going to be when you have SAS and SSS. Okay? So copy this down. I'll give you guys some time, and then we'll start to use it today. Obviously, these are just magical formulas that I gave you, and we need to make sense of where they come from. And we'll just do that tomorrow morning. It is, law of cosines is more complex. Okay? And one thing you will see is it's probably going to come somewhere from the Pythagorean theorem, right? Because you have the a squared plus b squared equals c squared in there, and then you're subtracting off this cosine part. So it's got to have something to do with the Pythagorean theorem, right? Yeah. Everything really has something to do with the Pythagorean theorem. I mean, not everything, but so many things, right? It's just such a huge thing. Pythagoras is a pretty smart guy. So it's going to be a good day already because you're going to learn something new already, and it's only second period because I don't think anyone, unless you've been looking ahead, have been working with laws of cosines. All right? Now, another thing, a nice thing about the law of cosines is you can use it on non-right triangles. Okay? You don't have to have a right triangle. It can be a right triangle. It'll still work on a right triangle, but it allows you a huge amount of flexibility to solve triangles. Find sides and angles of triangles. Awesome.
Is this for your other classes?
Yeah, they're working on linear equations. Yep. I need to make. We'll do one of those when we get. We'll do like a CMAS review, and we'll do one of those for a CMAS review. That's a good idea. Yep. Okay. So I'm going to give this another, let's see here. I'm going to give it another minute, and then I'm going to move on, and we're going to apply this thing, okay?
Oh, wow.
Okay. You guys ready? All right. So let's apply the law of cosines. Okay. So right now, copy down this triangle right here. Okay. And we'll call this example 1. Now, just for sake of time, can someone just give me the a, if we're using a squared, what is the a squared law of cosine? Kaylee, what is that? A squared equals what?
B squared plus C squared minus 2BC cosine A.
2BC cosine of A. Okay. So let's say that this, instead of Q, let's cross this out and let's just call this capital A. Sound good? Let's cross this out. If this is capital A, what is this have going to be here, guys? That's little h. And just what I'm trying to do is make it look like the formula. Is that okay? All right. Because, now let's cross this out and make this capital B. So what's this going to be over here? This is going to be little b. And we'll cross this out and make it capital C. And we'll make this little c. Okay? So remember, the opposite, little a lies opposite angle A. Little c lies opposite angle C. And little b lies opposite angle B. Remember, guys, side lengths are always lowercase letters. Angles are always capital letters. Okay, so let's use the law of cosines. Now, first of all, why could we not use the law of sines here? Why would this not allow law of sines?
This is side angle side, not angle side.
Yeah, but why? I mean, why just if we started doing law of sines, why would we get to a dead end?
You don't have two exact.
Right. You got with law of sines, you have to have one pair of given angle opposite sides, right? If you don't have that, you can't do it. So we could not do SAS does not work with law of sines. So what we're going to do is we're going to figure out A. You guys with me on that? We're going to figure out side A. Now, how do we do that? Well, to figure out side A, we're going to say A squared, because we don't know what it is equal to, okay, so what is B going to be, class?
36.
So, well, B is, so I'll just do this. I'll say 6 squared. I'll even write it out so you can see what we're doing here. Plus, what is C going to be?
8 squared.
8 squared minus 2 times 6 times 8 times the cosine of what? What is it? 80 degrees. Okay, now, here's where mistakes can happen. You have to be really careful. Okay, first of all, we have A squared equals, we've got 36 plus 64 minus, now we're going to subtract, this is one whole multiplication problem, right? So in your calculators, I want you to do 2 times 6 times 8 times the cosine of 80. And just give me a rounded decimal here let's go tenths place. Go hundredths place. Go 2 places to the right of the decimal. What is it? So we're getting about 16 point what? 67. Okay. Guys see that? Okay. Now, what the next thing we want to do is just add 36 plus 64 minus 16.67.
83.33.
So we get A squared equals what?
83.33.
83.33. Now, what's the last step here, class? Got to square root both sides, right? Remember when we do a square root, on both sides, we should do plus or minus, but we're talking about geometry. We don't have negative angles and negative side lengths. And so A is going to be approximately equal to what, guys?
9.13.
9.13. Now, would that, just looking at the triangle, does that seem like a reasonable answer here? Okay, so that looks pretty reasonable. Okay.
When we do this on the test, we want us to always round to the hundred.
We'll go tenths on the test. Yeah. Sound good? All right.
Yeah.
Now, we haven't solved this triangle yet, right, class?
No.
So, what we're going to do now is we're going to kind of reverse the law of sines. We haven't solved the triangle, and we have all the sides here, but we need another angle here, right? If we knew one of the angles, then we could use the triangle angle sum theorem to find the other one, right? But the problem is we don't know what these two angles are, so we're going to have to use the opposite law of cosine rule. Okay. So what angle do we want to find? I don't care which one.
Angle B.
B. Okay, let's do B.
Get on the level.
So if we're going to use angle B, someone give me the formula for law of cosines starting with B. B squared. Okay, hold on, Xavier. B squared equals what? Okay, minus 2AC times the what? Cosine of B. Okay, we are finding capital B. So now we're going to work backwards here. So, you guys ready for this? Instead of what are we going to put in for B? We know. So let's just put in 6. We'll not even square yet. So 6 squared. What are we going to put in for A? What is it? Yeah, we'll say about 9.13, and we're going to square that, right, guys? Okay. Plus, what are we going to put in for C? So we'll put in 8 squared minus 2 times 9.13 times 8 times the cosine of B, right? You guys with me on that? Okay. Now, any questions on what I've done here? Okay, definitely a calculator time here. So we know that we know that 6 squared is 36 equals, what's 9.13, guys? Squared.
83.36.
83.36 plus 64. Okay, now do this for me. Find this answer right here. Do 2 times 9.13 times 8. Tell me what you get.
146.
What do you get, George?
146.01.
So this one's going to be minus 146 point what, George? 08 times the cosine of B. Okay. Everything okay right now, guys? Okay. Now, the next step we're going to do is let's add these two numbers together right here. Okay? Just doing some algebra here. So add your numbers. Notice, guys, you cannot add this and this. These are not like terms. These two are like terms, but this one has a cosine of B on it, so it's not a like term. Okay? I've made that mistake before. It's not pretty. Okay. What is that? What's 83.36 plus 64?
147.36.
So I have 36 equals what?
147.36.
147 point what? 36 minus 146.08 cosines of B. Okay. With me? Okay. Now, next step. We're going to subtract off 147.36 from both sides. You guys see that? So now I'm going to subtract off 147.36 from both sides. 147.36 from both sides. What do you get there? You're going to get a negative number, which is okay. Negative 111 and 36 hundredths, okay? And that is going to equal negative 146.08 cosines of B. Okay, see that? Any questions there? Now, the next step is we're going to divide both sides by negative 146 points. And because this negative was connected to it right here, right? So it's definitely that negative's here. So we're going to divide both sides by the negative. And it is tricky, so you got to be careful here. Okay, now, so our answer is going to be positive, okay?
0.76.
So we're going to get, what is this, 146.08. Now I hear Martin's in my ear. What are you giving me, Martin?
0.76.
We're getting 0.76 equals the cosine of B. Now, what are you going to do? We're trying to find the angle, so what are we going to do now? You're going to arc cosine or inverse cosine both sides. So this whole problem boils down to taking the inverse cosine of 0.76. And what is the inverse cosine of 0.76, class? What? 40.5. Now, does that seem like a reasonable answer that would be a 40.5 degree angle? Sure. Yeah, we can round to the nearest whole degree. That's fine. So we could call that about 41 degrees. See that? And then it's just easy breezy cheesy here now, because now all we have to do is just do our triangle angle sum theorem, and that's going to be a 59. Now, you always want to check to see, does this make sense? is the largest angle opposite the largest side? Is the second largest angle opposite the second largest side? And is the third largest angle opposite the third largest side? If that's the case, we're probably in really good shape. You guys see that? Okay. Law of cosines is a lot more detailed. It's very tedious. Law of sines is a lot easier to use, but law of cosines is a little more tedious. Okay. So here's what I want you guys to do. I want you guys to try this example here. Okay. Let's do this. So let's just, for sake of easiness, let's just change everything. So we'll make this. What do you guys want to make that? C. And this is little c. And then we'll make this A. And we'll make this big A. And we'll make this B. And we'll make this little b. So normally, I mean, you just have to be able to, I'm not going to keep doing this, changing it to A's, B's, and C's. But I think it's just good for the first couple, just to kind of be able to look at your kind of your formula and just match it up to the formula. Does that sound good, guys? Okay, so let's first of all, let's go ahead and find little c first. Okay, so let's go ahead. I'm going to give you guys a chance. Go ahead and see if you can find Mr. Little C here. Okay, sound good? We don't know little c, right? You're good. And again, we have another SAS problem here, right?
Can you stop?
All right, Martin, brother, I'm going to do it right now so don't forget. Okay. What was the assignment?
It was the
Trigonometry number 1?
I think so.
I apologize for this. Sometimes we'll get you squared away, amigo. I'll look at it here.
It's the trigonometry homework number 1.
Trigonometry homework number 1.
Yeah. 89.
And you got it all done, Martin? Okay. Okay, Martin, it's done. Sorry.
You know how you got put my Delta Math as late, and you put it as like a B?
Yeah.
I think I know why it was late.
Why?
I was in California and I did it at like 11, and the time's an hour late, so I did it this time. But I was in California.
So you're saying you need it?
So I did it on time.
Okay. I'll see when you. No.
Thank you.
Do not let me forget to unshare. All right. Marty, if you don't mind, it's going to be recorded that I put points in your thing. Is that right?
Okay.
Yeah. I've already forgotten like 5 times. I'm worried that I'm going to forget. And I'll have that conversation with Chris about California time or whatever that is about.
Because it's an hour.
11:46.
Okay.
This isn't the real code. Now I see the hard part.
Let's find angle B. Sound good? Angle B, okay? But
You're not done yet. Imagine.
just for the sake of all of us doing it the same way, if you're ready to move on to angles, use angle B. Sound good? So that way we're all doing the same thing when we go over it. I'm not saying you have to be on angle B right now, but if you are, then I need you guys to work on angle B. Sound good? Not A. Well, it won't matter, but we're gonna use law of cosines on angle B. Let's do nearest hundredths on this. Sound good? And I'm not sure. We'll look at what delta math.
134.56 is 11. Wait, that's wrong. I square root of 134.8. Oh, because I rounded.
I don't care about the
Oh, we do 134.89.
Okay. Can someone raise their hand and just tell me what you got for little c? Little c. What'd you get, Esme? 11.64. 11 point what? 6.1. Okay. Raise your hand. I have my screen frozen. Sorry. Raise your hand if you have a number close to this. We're not going to split hairs over a hundredth place of a decimal. Okay. Are there any questions? Have some courage. Do not feel like if you didn't get this number, you got to have courage and ask a question. Okay? I don't want you to feel, hey, I'm not smart, everyone else got it. You have to have courage and raise your hand. Okay? Does anyone need us to go over this? I will absolutely do that. If I were sitting in your seat right now, I would have my hand up because I know at your age I would not have gotten this problem correct. I would have made like 12 mistakes. Okay. Okay. Now, if you don't mind, then we're going to say this is 11.6, which 6.1, right? Now, someone raise their hand and tell us how we can start angle B. How would I get a squared plus c squared minus 2ac cosine of b. Okay. Now go ahead and plug this in and see what you get. So this is where you would start if you're doing angle B. Okay? And we've all agreed that we're going to use angle B to find the angle.
Negative. Whoa. Y'all just did a lot of it. Oh, 0.7. Cheeseburger. Okay.
No, not 21.
That's
It's
cheese.
not. I was kind of sick.
Mr. Roden, the angle's the exact same as last time.
Is it really?
Mm-hmm.
All three of them are?
No, just B.
Just B.
So we can divide this. So
Okay. Would someone like to come up and just list their work under the board right there? Martin, you want to do that? Just come to the board here. Grab this. We'll take a look at your work. Share that green mark. There's markers up there. So, Martin, just start right here. Right here. Okay. Just show us your work, Martin. Sound good?
That's a lot of math. I can imagine that. Cody Brown.
Stop.
I can imagine what. Oh, wait, does it add up? Yeah, 41 and 50, that's close. 7.5. The first equation I understood, the second one I got cut.
Okay, you guys agree with the numbers he's putting in?
Yeah, the second one's so much harder and more.
I do.
Shush with the cheeseburger.
So let's go back.
Oh no.
No. No. Stop it.
You're on to the nearest 60, right?
Yeah, let's round our angles to the nearest whole number.
Yeah.
Oh, it does say that. Read till 20. Martin, just
We're so hot.
You guys pretty much liking Martin's numbers here?
So, yeah. Log, math, cosine. Yeah, you got the same thing.
Okay, Martin, step aside. So do we all agree that this problem is boiling down to taking the cosine inverse about 0.76, right?
Yeah. We got the same answers earlier.
Right.
40.5.
So these you just have to really, you have to be very tedious and careful. Okay, and you get about 41 degrees, Martin? Okay, and that would give us what for A then, Martin? Did you figure that one out? 50. What is it? 50 degrees, right? Okay, and so do the numbers line up nicely? Yeah, I think they do. Yep, perfect. Okay. All right. Now, let's try one of them with SSS, okay?
Will that be easier?
What do you think? Would SSS be easier or harder?
Harder. Bruh. Why? Why would you do this to us?
Why would SSS be harder, guys?
Because it's longer. That's because it's wide.
Right.
That angle is so
So,
harder.
you're so mean.
Why isn't there like two angles?
So,
Angle side angle.
SSS, you guys, and it tells me you guys are understanding this because SSS is going to require us to do the inverse cosine twice, right?
No.
All right. So have fun with that. Go ahead.
You guys, this will be the last one.
This will be the last one. So give this a try. SSS. Take it away, geometry.
Big N.
Yeah, I mean, it depends on. I mean, these are your notes, but I at least want you to do one SSS problem. Okay.
What is this?
Oh, okay.
Now, and I'm not even going to change it to little a's, little b's, and little c's, all right? You're going to have to be able to kind of adjust your thinking now with different letters. So if you want to change it yourself, that's fine,
I did not make
but we're not going to change it.
Yeah.
Why can't we just do straight up cosine, sine, and tangent on this?
Because it's not a right angle.
It's not a right triangle. Okay?
Right angle.
If this was a right triangle, yes. But if you don't have a right triangle, you have to use either laws of sines or laws of cosines. You can't use just straight up sine, cosine, tangent.
9 plus 36.
Good question there. Why did it?
7 squared.
Oh no, 2 times 3 times 6.
I'm gonna go ahead and stop sharing this. I'm gonna stop sharing this.